Good morning, Collision. Good morning, Mike, Sarah, and Manik.
Hello.
Thank you so much for joining us.
Pleasure.
We're going to have fun, and to dive in, let's confront the topic of this session. Mike, you've rearranged your whole life to spend a lot of it investing in climate tech companies. Is your goal to save the world?
I mean, I think I told you this, that I hate that framing because it sort of puts it into a humanitarian, sort of philanthropic framing. And I think what we need to do is get people excited about a better future where they like the products because they're better and they're cleaner and they're cheaper, not because of some like greater good. You know, when you drive an electric car, the sales pitch is it's fast and it saves you money on gas. You know, that's the sort of thing that we need to have, and that's why we have some companies here today whose products are fundamentally cheaper than what's out there today.
And are there other examples of things that are already part of our life that are climate friendly, but that's not the whole selling point?
I mean, I think you see this already in solar deployments. It is the fastest growing way to make energy, and it is inherently clean. It just sits there and pumps out clean energy all day long. It's now one of the cheapest forms of energy production out there, and is continuing to decline in cost. And I think just the very concept of batteries being everything. What's enabled EVs is, you know, at the core of it is something that looks a little bigger than a AA cell, just a lot of them, and they have come down in price 97% in 30 years. And that's why an EV is now feasible, and it wasn't before. So I think you're going to see batteries in a lot of stuff, which takes a dirty thing that emits toxic chemicals right where I'm standing, and get it replaced with something that's clean, quiet, and cheaper. And we're going to see a lot more of that happen in cars, and aviation, and boating, and a variety of other fields.
Sarah, tell us about what you're doing and why you're doing it, and why companies want to work with you.
Well, hi everyone. So at Dioxycle, we are developing a novel technology to basically clean up ethylene. You might not know what ethylene is, and it's normal, but it's, with a $200 billion market, it's the most used organic chemical in the world, and it's used in pretty much everything from like clothing, windows frame, pipes, auto parts, pharmaceuticals, medical device, you name it. So basically, right now, the way it's done is through breaking down fossil fuels. So you heat up a lot of fossil fuels, and you're going to break that down into ethylene. And this is a very, very emitting process. And so at Dioxycle, we are basically developing a technology that turns this process on its head. Instead of breaking down fossil fuel, we are building ethylene up from carbon emission, from waste carbon emission. And by doing that, we have the possibility, using renewable electricity, which is the power we use to do that, to displace the equivalent of 1 to 2% of the world emission. So I hope you will care about ethylene at the end of this discussion.
So building a material the world needs anyway, but doing that in a climate-friendly way.
Exactly, exactly.
And where are you on the continuum of making this something that can be produced at scale?
Yeah, so we are 3 years in the making. We've done a 3 order of magnitude scale up so far. We were at Stanford before, so it's really like a breakthrough technology that started from like a post-stamp size demonstration, and now we are needing a crane to lift our electrolyzer. And so that's really important because what we are building right now, this electrolyzer, is the final standardized size electrolyzer. And the beauty of this kind of technology, like solar, is the modularity of it, which means you first do a cell that can do that conversion of carbon emission into ethylene using electricity. Then you stack these cells into a stack, then you parallelize stacks in an array, and then you parallelize arrays. And that's very important because it means you can reach proof points faster, and so have like earlier on bankability, as well as like getting to like fast learnings, because now you're not making a huge one-of-a-kind plant, you're making like thousands of first-of-a-kind little cells that you are now putting together.
And are the companies who should be customers for this, are you in conversation with them, and are they excited for reasons that go beyond any altruistic aspect to it?
So I still think there is a lot of goodwill in the world. However, I have a plan B, which is the fact that we've reached with that technology a real breakthrough in terms of performance, which means it's super energy efficient. And in that process, since the energy you put in drives like 60% or even 70% of the cost, we managed to have a line on site on what is called like zero green premium or even negative green premium, which is like the overhead cost you usually pay for a sustainable product. So now it's scalable, cheaper, and also, I said scalable already, and sustainable, of course.
Manik, step us through what GlacierGrid is doing.
Yeah. Thanks, Harry. Love these kinds of technologies. GlacierGrid, like Sarah's company, we focus on a unsexy but critical problem, which is the world needs cooling. But the way we do cooling today is broken. Cooling, air conditioning, refrigeration are 100-year-old technologies that are essential for human flourishing. You know, they are what enable food, pharmaceuticals, even data. Data centers are basically cold boxes, and comfort. These are huge parts of the global economy, and yet cooling causes almost 10% of warming. And that feedback loop is getting worse because more people want cooling. Well, at GlacierGrid, we're trying to use technology to make cooling net zero, to make cooling not a carbon emitter, but a thermal battery. And so what we do is we use sensors, controls, and data science to turn dumb equipment into intelligent, controllable loads. But we don't do it because we tell people we want to save the planet. We do it because we want to deliver better, faster, and cheaper results. And I think that's the kind of reframing of the problem that we need to think about. What climate tech and what we're trying to do at GlacierGrid, I think, opens up is the possibility that you don't have to ask people to make sacrifice in how they get what they want. You can actually deliver people the kinds of results that make their jobs easier, their lives better, and in the process reduce emissions and help decarbonize. And I think that win-win is one of those rare opportunities to have your cake and eat it too. So that's us at GlacierGrid.
I know that you've been working with McDonald's. Sounds like potentially a very, very big customer for this type of stuff. What have the learnings been from that experience?
Yeah, absolutely. So we work with businesses in the food and hospitality space. So we're working with brands like McDonald's, 7-Eleven, Domino's, Marriott Hotels. These are businesses that deliver experiences, that deliver products to billions of people every day. Many of these businesses want to do the right thing. They're making net zero commitments, but they also need to deliver value. And so with a company like McDonald's, we're offering energy efficiency and energy optimization solutions that reduce operating costs, save users and staff time and money. I was in rural Arkansas earlier this week, installing and watching installs in 6 McDonald's around Texarkana, which is a part of the US I had never been to. I live in the Bay Area, grown up in the Central Valley of California. These are folks that are trying to do their jobs better and save time and money every day and deliver meals. And if we can reduce their utility bills by 10, 15% and help catch equipment issues, that's a win-win. And so that's the kind of value prop that we're selling McDonald's on.
I mean, when I first met you, Manik, I remember the image that stuck in my mind was, you walk into a McDonald's or a Chipotle or a restaurant, and there's a clipboard next to the refrigerator where every hour someone pulls out the clipboard, looks at the temperature, writes it down to make sure the food didn't get too warm, and then they use that to make sure it's safe. It's like, well, why don't we automate that? And once we automate that, we can optimize it. Once you optimize it, what you're doing is just saving money. And so the pitch is just like, hey, you're spending a lot of money you don't need to spend on this thing by putting a device on there and adding even 1990s AI technology into this. So there's so much optimization. And when I met Sarah, I spent 15 years building 20 million square foot of data center space. And you build that 1U by 1U pizza box. And then you put those pizza boxes into a rack, and then you put a rack into a building. And even though we build massive buildings now, you don't sort of build the whole thing in one unit. You build it in these units that you can scale up. We look at a technology like Dioxycle and the electrolyzer, the fundamental unit size looks like a pizza box, and then you put them together into a bigger rack size, and then you put those racks together into a facility. And so taking these concepts that people understand, automation, AI, scale up, and applying them to these really old, archaic industries that are ripe for disruption, there's a thing that gets me excited about this whole space, again, as an investor, not just as someone who cares about the planet.
And as an investor, is the world full of these opportunities waiting to be explored?
I think there's just so many static businesses out there that are waiting to get disrupted. I mean, just to make another thing obvious outside of these two businesses is we're in a world now in the United States where we had 2 or 3 decades of flat to declining energy demand. And now we're slated to maybe double our energy demand in the next 10 to 20 years. So you had a whole bunch of operators who are used to being like, how much do we need this year? About the same as last year. Great, go back to work. And now it's like, gosh, I got to double what we deliver in a decade. And that's creating all sorts of interesting challenges and opportunities and everything from transmission to production to transformers to all sorts of boring businesses out there. Not to mention solar and wind don't operate all the time. So we're used to put this asset on the grid, a big power plant that ran 24/7. Well, solar operates during the day, doesn't at night. So you have this huge variability during a day or during a season in power generation. So this sort of thing, and they're super cheap, so we're going to keep deploying lots of it. So this just creates a tremendous opportunity for optimization, for new technologies that can take advantage of low-cost intermittent renewables. So I don't have enough hours in the day to meet everyone doing cool things.
There have been periods where there's been a fair amount of concern that our most entrepreneurial people were focused on starting companies in glamorous consumery areas rather than these areas that are somewhat mundane but potentially very impactful. Since all three of you are involved in working with people in the startup community, is that an issue, or are the people you would hope be excited about being part of these companies genuinely excited about joining the cause? Sarah, maybe I can start with you.
Yeah, well, I think the first thing we have to remember is that it's still a business, so it still has the same functions as other business. I mean, we just recruited a CFO. Now we are transitioning at Dioxycle, from like R&D to more like commercial demo deployment. We are also looking at other type of functions like business, etc. So it's very similar to another type of business. The beauty, I would say, of climate tech in particular is that it's less of a mature industry compared to other industries. And so it means that since we are very often developing end-to-end technologies, like you can have a mix of competences within a team. For example, at Dioxycle we innovate at all levels. We bring in like software, data engineering, mechanical engineering, chemistries, process engineering, and so there is a chance for super ambitious people with like a will to have a lot of ownership, a lot of scope, to come in and be really at the center of something where they see all the parts coming in together and not being in a very specialized function as in more established industry. What do you think, Manik?
Totally agree, and I think to Sarah's point, I mean, we're building businesses. Climate technology is still about building technology-driven solutions at scale. That's a business problem. I think what's exciting is for young people and for people who want to reinvent their careers, the returns to that effort could be greater, both economically and the spillovers could be greater for society in the climate category. You have a bunch of technologies over the last 20 years that got more and more mature in consumer and business applications, and I love those. I would never knock those. I mean, I like my pizza delivery, I like my photo sharing. I've got a 3-year-old. I use my consumer apps all the time. But what we see with climate is you've got 100-year-old sectors that people haven't worked on, and we've got approaches, product-driven growth, the ability to deploy venture capital at scale, building cultures of excellence. Those approaches have been working really well in consumer and business technologies. We can take those and bring them to big problems and drive more return. You can make more money for your investors, for yourselves, for your teams, and create wins for the world. So I think that's why people are flocking into the space. We're seeing more applicants than ever, and I think there's going to be more climate capital in the years ahead.
Yeah, I'd say I have a conversation every single week from someone from oil and gas, from the space industry, from big tech, who says, look, I want to help with the climate crisis. I care about this. I care about people being able to live well. I just want to know that it's an actual interesting career opportunity for me, and I can support my family. And so that's the thing that people need to understand is, as Manik said, there are great business opportunities here for people to do work that they are proud of and are excited about.
And some of the skills that people might apply to any sort of startup are useful here versus it absolutely requiring unique skills that could not be applied to some other startup field.
I mean, you still have to deliver value. If you're building climate tech solutions, you have to make people's lives better, make their work easier, help them either make money or save money or achieve what they want, in their personal lives. Those problems are still ultimately about delivering great user experience, doing it in a way that's intuitive, that's easy to access and scale. And so the skill sets needed are similar to what's been developed in other sectors, but because these industries are less mature and there are fewer players working on these, there's just more opportunity, which means the kinds of jobs you can take on are more cross-cutting, you can pick up skills faster, you can actually get outsized personal opportunity and professional opportunity, but the underlying skills are still very similar, I would argue.
Yeah, I agree. I agree. I think there's a risk to think that climate tech is different also because it's like, I mean, as an entrepreneur, if we don't go to the talent, but to the entrepreneur side of it, for anyone wanted to build a company, I think it's important to remember that we have to start from the consumer experience, how desirable is the product, and work backwards towards the technology and not be technology-centric. I'm saying this because I'm a technical founder, I have a PhD, and you can fall into that trap of like really willing to push technology. No, it's a business, so you have to like make it cheap, make it scalable, desirable, etc. And so that's really important as a starting point.
We would probably be remiss if we didn't wedge a reference to AI into this panel, so I'm going to do that. Is there an AI sustainability story, and is AI an accelerant for some of the things you're doing in a way it is in other categories of business?
Manik, you should talk about AI in your field.
Mike thinks about AI more than I do, but I think about AI a little bit, and Sarah probably knows more about AI than I do. I'd say we see opportunity in a very practical sense when you have a simple closed ecosystem of controls. When you're trying to turn stuff on and off, say an air conditioner or refrigerator, when you're doing that across thousands of assets and looking at the temperature and trying to make sure you don't spoil products or make guests and workers unhappy by making it too hot, there are rudimentary ways to solve that. You can turn stuff off when no one's there. You can turn stuff off when the businesses, or for example, we work with 1,000 schools. Schools are closed. You can turn stuff off when no one's in the environment. But doing it at scale and doing it better and better, ultimately using techniques from machine learning can allow us to get self-learning systems so that we can do it better in a McDonald's versus a Taco Bell, a Burger King versus a Domino's. And so I think there are opportunities to deploy real algorithmic approaches to solve practical business problems. We're starting to do that. I'm sure you see many of these, Mike.
Yeah, I mean, I think of AI a lot, and so, because I still wear one hat where I help Meta with Llama and other things like that, and I think of AI as both a challenge and an opportunity. So, I mentioned growing power demand in the United States can about double in 10 years. There's really three core drivers of that. The first is onshoring of manufacturing, the second is the EV transition, and the third is data center growth, most often driven by AI. So AI is creating a tremendous increase in power demand, which is the challenge that it's presenting us. And then the opportunity, as Manik said, is it is a powerful foundational technology to help us optimize a whole lot of things. So there's a lot of people with clipboards out there still running, or a lot of big panels with switches where you're just sort of looking at gauges and switching things. And by optimizing that 1 to 3 to 5 to 10%, you basically have this win-win-win where you get basically savings in money, time, and others. And the deployment of AI to any of those industrial systems is basically 0 point something percent. So there's just a tremendous opportunity to take even current technology to do that. And as technology advances, it's going to allow us to make higher and higher level decisions in these systems. So optimize not just at a plant level, but across an entire industry.
I would add to that like one of the big challenges, though, for example, in chemistry, is access to data, especially when it comes to industrial processes, because a lot of these data have been like proprietary data from like the big industrial players. So I would say, for example, in our case, we do a lot. I mean, we have software. We have a lot of like work in the back end on like analyzing data. We have tens of test bench turning all the time to accumulating this data, and I see a lot of companies starting saying, yeah, we are a material discovering company, and that's really exciting. I do want to know about, if it's about protein folding, of course, like the data is available. If it's about like industrial catalysts, I think there's still like this challenge to bridge, and a lot of opportunity is going to be between this sort of hardware, software, data access space.
I mean, I think there's a lot of opportunity. I was just at University of Toronto lab yesterday where they're basically running high throughput experiments on a variety of different materials for catalysts. And this is actually a collaboration with Meta and the Open DAC project, and they're using AI models to basically explore, to generate, just like we'll generate text for your chatbot, we can generate ideas for molecules that might work for a catalyst. We don't know if those ideas, they may be just as dumb as a hallucination in my chatbot, but you try them out and there might be some interesting discovery there. So it really is increasing the speed at which we can iterate as humanity in discovering new materials which may perform better than things we're using in the past.
That's a great note on which to end. I'm excited. I can't wait to see what happens next. Thank you so much for your time, and thank you, Collision.
Thanks, Harry.
Thank you.
Thanks, Harry.
Pleasure.